Hey developers, welcome to Devcovery. Today, we're bringing you the hottest open source projects trending on GitHub, so you don't miss any tech developments worth your attention.
Today, we're taking a deep dive into a trending project on GitHub, SpacetimeDB, a database built by clockworklabs that promises to radically simplify multiplayer application development by embedding your application logic directly inside the database. It earned nearly 1,000 stars on GitHub just today, challenging the traditional boundary between backend servers and databases and opening up a fundamentally faster way to build real-time, stateful applications. What if you could delete your entire backend infrastructure, the web servers, the microservices, the containers, the Kubernetes clusters, and replace all of it with just a database? That sounds like a fantasy. But that is exactly the premise behind SpacetimeDB. And the developer community is paying close attention. Over 20,000 GitHub stars, with nearly 1,000 added in a single day. SpacetimeDB is a relational database system built by clockworklabs. The core idea is simple but radical. Merge the application server and the database into a single unified entity. Instead of deploying a separate server layer between your clients and your data store, clients connect directly to the database and execute business logic inside it. The tagline "development at the speed of light" is not just marketing copy. It reflects a genuine architectural philosophy. Eliminate network hops, eliminate operational overhead. The project is written in Rust. It has accumulated over 20,000 stars on GitHub with 719 forks and is gaining nearly 1,000 new stars per day. clockworklabs has already shipped a production MMORPG called Bitcraft Online, whose entire backend runs as a single SpacetimeDB module. That is a credibility signal that is hard to dismiss. To appreciate why SpacetimeDB exists, consider how most real-time applications are built today. A client sends a request to a web server. That server validates the request, applies business logic, then queries a separate database, waits for a response across a network boundary, processes the result, and finally sends it back to the client. For a chat message or a game state update, this round trip introduces latency at every single seam. Multiply that by thousands of concurrent users, and you get a system that is both slow and operationally complex. Web servers, load balancers, message queues, containerized microservices, and a DevOps team to hold it all together. Developers have historically compensated by caching aggressively, using WebSocket servers for real-time push and building elaborate state synchronization layers. Each added layer is another failure point, another service to monitor, another configuration to maintain. The fundamental question SpacetimeDB asks is, what if the database itself handled the application logic, authorization, and real-time state broadcasting, making the intermediate server layer unnecessary? The core innovation is what SpacetimeDB calls modules. These are units of application logic written in Rust or C, number that get compiled into WebAssembly, a portable binary format, and uploaded directly into the database. When a client triggers an action, the database loads that WebAssembly module, runs the relevant function called a reducer inside a sandboxed environment, and commits the resulting state change as an atomic transaction, meaning it either completes fully or not at all. Think of WebAssembly here as a secure shipping container. It lets foreign code run inside the database without being able to escape and corrupt the host system. For performance, SpacetimeDB keeps all application state in memory. Every player position, every chat message, every game object lives in RAM. Writes are persisted to a write-ahead log, a wall, which is an append-only record of every change. This is the same durability mechanism used by PostgreSQL and other production databases. If the server crashes, it replays the log on restart to reconstruct the full state. The result is read and write latency measured in microseconds rather than milliseconds. The third piece is reactive subscriptions. Clients declare queries they care about. When any reducer modifies data matching those queries, the database automatically computes the diff and pushes only the changed records out to all subscribed clients. No polling. No separate WebSocket infrastructure to build. The database handles state broadcasting natively. To make this efficient, SpacetimeDB uses a custom binary serialization format called bsat-n, which significantly reduces data volume and CPU cost compared to JSON over the wire. The primary target is developers building applications where state must stay tightly synchronized across many clients simultaneously. Online games are the clearest fit. Player positions, inventory updates, and environmental changes need to reach every connected client within milliseconds. Bitcraft Online, the studio's own MMORPG, validates this at scale. The entire game world, including terrain, resources, player locations, and chat, is managed by a single SpacetimeDB module with no additional server infrastructure. Beyond games, the architecture maps well onto collaborative tools, shared whiteboards, real-time document editors, live dashboards where multiple users must see a consistent view of the same data without conflict. High concurrency messaging systems, chat applications, customer support platforms also benefit from the low-latency push model. Getting started is 4 steps. Install the Spacetime command line tool. Start a local standalone node. Write and upload a module in Rust or C number. Then connect using one of the provided client SDKs for Rust, C number, or TypeScript. For developers already comfortable with Rust, the on-ramp is relatively shallow. Community feedback data was not available at the time of this analysis, so this section reflects the broader context observable from the project's public signals. The star velocity, nearly 1,000 in one day for a project at 20,000 total, suggests viral spread rather than a first-time launch. The existence of a production MMORPG as a proof of concept generates credibility that purely theoretical database projects simply lack. That alone tends to drive substantial developer curiosity. The Discord and active social channels indicate an engaged maintainer team. The license Business Source License 1.1, which converts to AGPL version 3.0 with a linking exception after several years, has historically been a topic of debate in open source communities. BSL is not an OSI-certified open source license and carries commercial use restrictions during the conversion window. Worth understanding before you commit. The architecture's strengths are also its constraints. Keeping all application state in RAM means the dataset size is physically bounded by available memory. For an MMORPG or a chat application, this may be entirely acceptable. But for applications approaching hundreds of gigabytes of active state, the cost curve becomes steep and horizontal scaling becomes a genuine engineering challenge, one that traditional distributed databases have spent decades solving. The deeper concern is architectural lock-in. When business logic is compiled into WebAssembly modules and embedded inside the database, migrating to a conventional stack at a later stage requires a full rewrite. The lack of separation between data layer and logic layer, normally considered good engineering practice, becomes a liability when requirements change. The BSL license also deserves a direct mention for any team evaluating this for production use. The restrictions on commercial use before the license converts may create legal ambiguity that procurement and legal teams at larger organizations will flag. Convex.dv occupies a similar architectural niche and is worth evaluating alongside SpacetimeDB. The key differentiator, SpacetimeDB's Rust and WebAssembly execution environment likely handles compute-heavy workloads more efficiently than JavaScript-based alternatives. SpacetimeDB is a genuine architectural bet. The premise, for a specific class of real-time, stateful applications, collapsing the server and database into one system produces better performance and lower operational complexity than the traditional 3-tier stack. The Bitcraft Online deployment proves the concept works at production scale. Whether this approach belongs in your stack depends entirely on whether your application fits that profile. But the idea is worth understanding regardless.
That's all for today's Devcovery. We hope these GitHub trending projects spark some inspiration for your development work. You can find all the repos mentioned in the description below. If you enjoyed this episode, don't forget to subscribe to our channel. See you tomorrow at the same time.